Assalamualaikum and hello everyone. Welcome back to our class on Introduction to Machine Learning, and I'm Dr. Marani Abu Bakar, the instructor of this course. We will continue to discuss more about the support vector machine. So for the review from the last lecture, we have learned the concept of hyperplane, which divides a space into two classes. Remember, called +1 and -1 class, right? So the hyperplanes divides the data set into two classes. Remember that? So that's why it's called the binary classification problem, right? Because the hyperplanes function of the hyperplanes is divides the data set into two classes. It's called the +1 class and -1 class, right? And then we also learn the margin, right? The concept of the margin and the support vectors, which are the basis on building the hyperplane, right? So let's move to the maximal margin classifier, because not all of the margin that we need the maximal one or the optimum ones, right? Okay, now we'll give you example about how we use the support vector machine to solve the classification problem, right? Okay, we'll do it manually, but then later on in the lab, okay, you can use the Python, okay, to solve many data sets, okay, to classify the data. All right, let's begin. Okay, let's say here we have 3 points, all right, x1, x2, and x3. Alright, we give you here x1 and x2 are negative class, so it means the two data points lies on here. This one is negative data class, whereas the 6 3, which is about here, right, that one is from the positive class. Alright, now the problem is, what is the function of the decision? It means what is the function of the hyperplane here? What's the function for that? Okay, so as we know, the function of hyperplane has like this, right? The formula W transpose X plus B. Okay, so we need to determine W, weights, and bias. Okay, now let's start. Okay, from the points or from the data set that we have now, we can just put in the formula first, right? So here we have the negative class x1, x2. So we have to put it in here, right? W transpose X plus B equals to -1. Alright, because here in 2D, right, x1, x2, x3 is in 2D, so we have two weights like this, right? W1 and W2, right? So and then we do it one by one. So this one for the x1 first. Okay, so basically W transpose x1 plus B equals to -1. Okay, now we substitute, because we have x1 is 2 1, so we have W transpose vector 2 1, because into D, right, the x1 plus B equals to -1. Okay, so because here we have 2D in the 2D vector, then W transpose became W1 and W2 in the vector, but in the we transpose it normally like this, right? We have W1, W2. Now transpose for this, we have W, W2. Okay, so we have this one, and then we just compute W1 times 2 is 2W1, and then W2 times 1 is W2, and then plus B equals to -1. Let's say here is a one star equation, let's say, right? And then similarly, we have the second point, which is 1 3, right? So we do it the same way. So we have W transpose now times 1 3, all right, plus B equals to -1. Then we have double star, equation double star. Okay, for the third point, which is 6-3, here it says it's a positive class, right? So instead of -1 here, we change with a +1. Okay, so similar formula, but only this one is different. So we have W transpose 6-3 plus B equals to 1. Okay, so we have triple star. Okay, now we have 3 equations. Okay, this is the first one, second one, the third one. Where is it? This one. So we have to solve it. So if you remember a system of linear equation, so we can do it one by one, or you can use elimination method maybe. Okay, so for instance, we start from star 1, subtract with double star, for instance. So we just put here now 2W1 plus W2 plus B equals to -1, and then we have the second one, W1 plus W2, 3W2 plus B equals to -1, like this, right? And then we have common variables like B, for instance, and then we just subtract it because we want to delete B. So we have here, not delete, we will cancel the B. Okay, so here 2W1 subtract with W1 equals to W1, and then W2 subtract with 3W2, we have negative 2W2. This one is 0, this one also 0, then equals to 0. So from here we have W1 equals to 2W2. Okay. So here we have equation star, 4 stars. Okay, what's next? So you do the same thing. Previously we have 1 star and 2 stars, right? Then you can use now equation from double star and subtract with triple star. So we do it one by one. Okay, and then we just put like this, W1 plus 3W2 plus B equals to -1, and then the triple star, 6W1 plus 3W2 plus B equals to +1, right? Okay, so just subtract it. This one cancel, W2 and W2, right? B and B also cancel. We just have -5W1, -1 subtract -1 equals to -2. So W1 equals to 2/5. Okay, so W1 equals to 2/5. So we can just substitute in triple stars. Okay, so triple star we have W1 equals to 2W2. So W1 is 2/5 equals to 2W2. Then W2 equals to 2/5 divided by 2. Okay, or multiply with half. So this is cancelled, then we have 1/5. Okay, now we have W1 equals to 2/5, W2 1/5. Then the rest one is B. So how we got the B? Just substitute W1, W2 into one of the equation here. You can just put it in the star 1, 1 star, 2 star, or 2 star, and so on. Okay, let's say we just substitute in 1 star here. Okay, so from here, okay, this is the first star, right? 1 star. So 2 times W1 is 2/5 plus W2 1/5 plus B equals to -1. Okay, so here we have 4 over 5 plus 1 over 5, we have 5 over 5 or 1, right? So we have 1 plus b equals to negative 1, then b equals to negative 2. So b equals to negative 2. So that's why here we have w1 equals to 2 over 5, w2 1 over 5, and b equals to negative 2. Okay, so once we get weights and values, then we can just put it in this hyperplane function. Okay, so the function now that we have, so the equation here, right, is the 2 over 5, 1 over 5, and then x1, x2, negative 2, right? From here, this is equals to 0. But it's 2 times I'm gonna write this in another color. So we have 2 over 5, 1 over 5 like this, and then here x1, x2, negative 2 equals to 0. Right, so we have 2 over 5 x1 plus 1 over 5 x2 negative 2 equals to 0. So the equation here, if we don't want to deal with the fraction, we can just multiply with 5. Then we have 2x1 plus x2 negative 10 equals to 0. Let's try it again. Here 2x1 plus x2 negative 10 equals to 0 if you don't want to deal with the fraction. So this equation, this line has equation like that because this one's equals to 0, right? So equals to 0 means this is the equation, whereas this one, the left one, the negative one, has the function as 2x1 plus x2 negative 10 is less than 1. Less than 0. And here is blah 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 2x1 plus x2 negative 10 is greater than 1. Greater than 0. So something like that. Okay. Okay, we continue again. So this is the illustration for our data sets here. Data sets x1, x2, x3, and this is the boundary, the decision function or boundary function. Okay. So this one, remember, 2x1 plus x2 negative 10, right? X2 0 and so on. Okay, now this is actually from the Lagrange multiplier, or from the Lagrange multiplier we have this equation, right? So we can also determine alpha I, the multiplier. Okay, so how to determine the alpha I is from here, from this equation. Okay, alpha 1, because we have 3x, right? 3xi, then we have we should also have 3yi, which means the target one. Okay, so we have here like that, alpha 1 plus y1 plus y2 plus y3. Okay, so at the moment we can just choose or use yi equals to 1, all of them. Then we have this one. Okay, so from here we have alpha 3 equals to alpha 1 plus alpha 2. Alright, since we have this equation, okay, then we just substitute w, because we already know the value of w, right? I just put it here, 2 over 5, 1 over 5, and then here negative alpha 1 times x1, right? This is x1, and negative alpha 2, this is x2, and this is x3. Alright, so just multiply as normally. So here we have negative over 1, negative over 2, plus 3 over 3 equals to 2 over 5, and so on. And then we solve it. When we solve it, we found that alpha 1 equals to 0, and alpha 2 equals to alpha 3 equals to 1 over 10. Okay. Okay, so to summarize, the support vector machines aim to find the best separating boundary, the one that maximizes the margin between classes. So we have seen the mathematical formulation, the role of support vectors, and how SVMs can be extended using the dual formulation. Okay, thank you for attention, and in the next session, we'll explore how we can handle non-linearly separable data using kernel methods. But I think for this one, we can just go for the practice in the lab. Okay, thank you very much, and see you again. Bye bye.